Welcome to a demo of Datadog's Cloud Cost Management solution. As DevOps team lead, I often have to make sense of messy, hard-to-access cost data to help finance and leadership understand why our costs changed. But this year it's different. Our engineering leadership is asking everyone to monitor costs as KPI for the applications they own. As a DevOps lead, our Cloud Cost Management overview page is the ideal place to get a high-level picture of our overall cloud spend. I can see Microsoft Azure or AWS costs. I can quickly understand month-to-month spend trends and easily spot any unexpected growth. Immediately, I noticed that our overall spend in the last week has increased. Cloud Cost Management breaks down the cloud bill through a simple integration with our cloud provider and makes it easy for me to allocate changes in spend to specific teams and services. I can quickly understand our cloud bill by using Datadog's out-of-the-box tags, and any custom tags already in our cloud environment are automatically ingested. Cloud Cost Management automatically surfaces the past week's biggest cost change by product, team, and service. By having all this data in one place, I can quickly pinpoint that our web store service had a spike in spend. I need to investigate this further to see what happened. To get a better understanding of what's causing this increase, I can access the web store team's dashboard. This is the performance dashboard for the web store service, which includes cost data in addition to the usual KPIs my team tracks week over week. I can see here that our cost per checkout for this service has increased in the past few days, but our number of checkouts over this time period has stayed relatively the same, which means our costs have increased. Datadog lets you calculate unit costs using any standard metric like requests or custom metric like the number of checkouts. Visualizing this cost data here, scoped to the services this team manages, facilitates a fundamental shift. The web store team can notice changes like these on their own and address them proactively instead of waiting for an email to come in from our DevOps team or finance. Next, I'll investigate the service costs to understand why they increased. This section of the dashboard shows the AWS products powering my web store service. In the past 4 days, my EC2 costs doubled, which is driving the increase in cost per checkout. I want to understand what EC2 instances our service is using and how they're performing. Breaking out my EC2 instance usage in our host map shows that many of our 32 extra large instances are underutilized. These instances not only have low CPU utilization, they also have low memory usage and make up a significant portion of my EC2 spend. By using Datadog, I'm able to quickly see side by side the cost and usage of a specific instance type. What would have usually taken me multiple exports is right there, available for me to act on. If the service is supporting the same number of checkouts and my instances are underutilized, it's possible the team spun up more instances or migrated to a larger instance type. To confirm what changes in our instances were made and when, I can use Cloud Cost Management's analytics page to drill down further into our web store's EC2 costs over time. With this analytics page, slicing and dicing across all my cost data is fast and intuitive. I've already grouped and filtered this portion of our bill by my web store service. We're able to group by up to 3 fields and custom tags to speed up our investigation and quickly find our way back to our EC2 spend, something that's impossible to do with native tooling. I'll group my costs by AWS products, and if my service were running on Kubernetes, I could also group costs down to the individual cluster or pod by leveraging Datadog's existing agents, no additional agent installation required. By clicking into the EC2 row for my service, I can get more granular information to confirm how many instances this service is using, along with its cost per instance. The number of instances did increase, and when I scrolled down to look at which instance types were used, the web store service went from using i3EN 24 extra large instances to a larger and more expensive instance type, i4i 32 extra large. The web store team might have changed this instance type to accommodate a new customer or ahead of a launch. But since I know that CPU and memory are underutilized from looking at the service owner's dashboard, I'll want to confirm with them why they decided to both increase the number of instances they use as well as increasing their size. I'll directly export these findings into a notebook so that I can quickly close the communication loop. I can tag the web store team's service owner in this report, providing them with a complete context of my investigation and creating a clear set of next steps. Once that's complete, I can share a link to this back to my finance team to help them understand how this change will affect our overall cloud costs in the coming weeks. And since the web store is one of my most expensive services, I want to be notified of any changes like this in the future. The metric to monitor is automatically filled out, and it can be set by percentage change over time. Anytime the cost of this service increases by more than 5% day over day, both myself and the respective team will be notified to ensure there are no more surprises in our cloud bill. So, in just a few minutes, we've gone from identifying anomalous spend to finding the root cause in order to share this back with the responsible service owner and monitor this in the future. Cloud Cost Management enables our DevOps team to investigate and create actionable insights from our cost data quickly and efficiently, all in the same pane of glass that our engineering teams already work in to foster cost ownership across the entire organization. To take control of your cloud costs, start a free trial directly on our website.